Hello, Earth Science. In addition to what I talked about in my last lecture video, I want to show you a couple cool graphics I found. I'm going to be putting links to the graphics in the agenda. But this is a solar radiation infographic. So what this person is showing is just how much heat the sun, or sorry, how much so how much what heat goes to the earth and then what heat is reflected or released from the earth. And it's really cool. I'm not sure exactly what all these percentages mean. I'm going to figure that out soon. But you can see that, some sunlight is reflected from clouds, some is reflected off the earth, some is reflected into the ground and some the atmosphere, some of the atmosphere or some of the atmosphere absorbs some of that heat, the absorb some of the excuse me, and the atmosphere releases some of that heat, and even the earth releases some heat. So the point is that not every piece of sunlight that hits the earth or the earth's atmosphere is absorbed. Not all of it goes into warming the earth. The earth reflects a lot of heat. The earth absorbs some heat, and then the earth will absorb and release some of that heat. So, and the main point is that if all that heat is just absorbed by everything, we'd be fried. The earth would be way too hot. So we need some of the heat to be released or reflected in order for us to have a suitable environment. And let me show you another cool simulation. So here's another simulation. So this one you can kind of see, here's the sun and here's the earth. We'll talk a lot more about the diagram we're looking at when we talk about astronomy. But anyway, you can see the sunlight coming towards the earth, and there's two little bars that lets me control here. I have either weak or strong solar radiation and heavy or small greenhouse gases. So right now, the Earth is at a steady 20 degrees Celsius. That's just saying the average temperature of the Earth is an average 20 degrees Celsius, or that's also 68 degrees Fahrenheit. Watch what happens if I increase the greenhouse gas. The temperature starts to go up, and it doesn't just go up instantly. It takes a little while for the Earth to warm and go up a little bit more. And what he compares this to is the whole Sun-Earth system here is kind of can be compared to like a faucet dripping into a jar with a hole in the jar or the glass, whatever you want to call it. So again, remember that previous diagram I showed you, so it showed that some sunlight was absorbed by the earth, but not all of it. A lot of that sunlight is released in one way or another. But if I cut the width of this hole right here at the bottom, where the one that's leaking out, if I cut that shorter, then my glass begins to fill up. And that's kind of a clever analogy for explaining what greenhouse gases can do to the earth. I need some greenhouse gases because if I just turn off the greenhouse gases altogether, my temperature starts to really plummet. And we can't live in a cold earth not much more than we can live on a warm earth. So now my glass is emptying. We need some heat on the earth. But of course, too much, and the temperature goes up like crazy. So there has to be a good balance of greenhouse gases. So just think about that as we talk about global warming today, and for this rest of this week, we're going to be thinking a lot about greenhouse gases and the impact they have on our environment. So I hope you liked these little analogies, this demonstration, and I'll put the links to these two simulations in case you want to go check them out yourself and play around with these settings. I'll talk to you later.